So again, this tutorial will talk about last two sections, triple integral, cylindrical coordinates, and after page 7, starting from page 8, I put the test from 2019 right here, so you can give yourself 110 minutes, which is 1 hour and 15 minutes, to work on this, and it should be a really good practice. Just treat it as a real test. The only problem with this test is that they don't cover cylindrical coordinates, so you might need to add one more question for yourself. So I don't think I have time to do example 5, so you can put it as part of the test. And here is a question asked, how much time do we have for the test? I don't know any information about your test yet. All I know is that it covers from section 15.1 till 15.7, which is what we're doing today. And I think it's in lecture time. Yeah, Thursday it's an hour. I'm not sure yet. Yeah, I don't know how long it's gonna be your test. So Thursday lecture is only 1 hour. I feel like if it's 1 hour, that's pretty short. So let me check. I actually don't know. She didn't tell me anything. Thursday first midterm. Yeah, probably ask her tomorrow. I really don't know how long it's gonna be, but I think at least this should be a good practice. But this test was 1 hour and 15 minutes, so give you 1 hour and 15 minutes. I don't know. Honestly, I have no idea. Anyway, let's do tutorials. So go back to triple integrals. So before we had double integral, which was on a rectangle. So right now, triple integral would be on a test, on a box, over a box. So the box is like this box. Okay, this is your B. And you can use Riemann sum, which will be you are splitting the big rectangular box into small boxes like this. So that is, you use Riemann sum, but most likely you will not use Riemann sum. You will do the computation integral directly. So if f is continuous, a rectangular box B, which is a to b times c to d times r to s, then the triple integral over b equals to this. So it's really similar to double integral, except you are adding one more typo. Sorry guys, didn't see the typo. Should be z here as well. So fxyz. Yeah, because I copied from double integral and forgot to change that. Okay, so anyway, that's for over a box, but most likely you will not get a box. You will get a general solid. So in this case, we will have 3 different general region or solid region. And in this case, type 1 is saying that it lies between the graph of two continuous function x and y. Oops. Okay, so your xy is in D, where D is just like the region we talked before in double integral. So this region is a projection of E onto xy plane. As shown below, I'll show you the graph in a second. And your z is in between u1xy and u2xy. And those are the upper and lower boundary of the surface. So this is a type 1 solid region. So you can see that your D is a projection onto xy plane. Okay, and the upper bound is u2, lower bound is u1. u2 and u1 are functions of x and y. So that's type 1 solid region. But for D itself, so for this projection itself, we have two different types as well, right? Oh, by the way, if it's type 1 region, this is a formula you use to compute it. But for D itself, we have two different types. We have type 1 and type 2. The definition is exactly the same as before we do double integral. So type 1, then your x is in between two numbers and your y is in between two continuous functions, and z is still in between u1 and u2. And for type 2, it's the other way around. Your y is between two numbers, your x is between two continuous functions of y, and then your z is between u1 and u2 as before. And if you have D is type 1, then this is how you compute it. D is type 2, then this is how you compute it. And if you look at the graph, I put two graphs here. This is type 1 solid region E on type 1 D. And this is type 1 solid region E on type 2D. So this means that for each solid region, you have two different plane region. Okay? So that's one. Type 2 region is in this form. So before we have xy in D, so we were talking about xy plane. Now we're talking about yz plane. So if you're talking about yz plane, then the other variable will be x. So x will be in between u1 and u2. So just like this. Okay, and this is the formula to compute it. And lastly, we will have xz plane. So if xz is in D, then y is going to be in between u1 and u2. And then you would have xz plane. And for all three different regions, you need to think about if your D is type 1 or type 2 plane region. And that's going to make a difference as well. But when you do the questions, it's not that complicated. Okay, so let's try example 1. I'll give you some time to try this and I'll take it up when you finish the question. Let me know when you're done. I think I forgot to answer one of the questions. Other solutions to this past exam. I will give you the solution. I will post it on Quarkus after. Probably not today, but well, probably tomorrow. I'll post it tomorrow. Just check Quarkus. Do you want me to send an announcement after I post the solution? Or you just check yourself? Okay, cool. By Wednesday. Yeah, I I will post by Wednesday, definitely. I'll probably write the solution today and then post it tomorrow. Cause like I wanna give you guys some time to work on this. If I post it today, I think a lot of students will check the solution directly instead of trying the questions themselves. So I think it's better that I post it later. Wait, not x, z equals to x, y, and z equals to 0. Okay, I'm done writing, so I'll take it up now. So basically, this equals to this, which what I'm doing is y is between 0 and 1, so your bound is 0, 1 for dy, and x is between y and 1, so your bound for x is y and 1, and z is from 0 to xy, so dz. And the rest is just integration, so yeah, the rest is just integration. There is nothing complicated. You might need to use integration by parts somewhere here. Yeah, integration by parts here. And the rest is just computation. Any question for this? This one should be fairly easy. There is nothing complicated involved. Okay? Question? Are we good?
Liang, I just noticed something.
Yeah.
Right when you're doing the integral with respect to set, you put y e to the xy on the first line.
Yeah.
Should you include like a set? Because so that expression e to the x over y is all constant. So if you integrate with set, just be said e to the xy.
I see. Yeah. the question I did is different from the question you did. Here should be Z over Y. Sorry. Yeah, that's why. It's a typo.
Oh, it's set over Y. Okay, yeah,
Z
because.
over Y, not X over Y.
Oh, okay.
I
Yeah,
see
so I
it.
did a different integral. Okay.
Yeah, it's different.
Yeah,
Let me
thank you.
fix it. Z over Y. Just let me double check because I took it from a textbook. Now let me find the textbook. Yeah, it's Z over Y. Yeah, because I was doing the question and probably typed it wrong. Z over Y, and then here should be Z over Y as well, right? Yeah, Z over Y.
Yeah, looks good. Thank you.
Z over Y, and yeah, the rest should be good. Any other question? I guess I'll fix it later on the LaTeX file and I'll post the final solution as well. Okay, so example 2, it says the solid, oh, you need to calculate the volume of the solid enclosed by the paraboloid. So I'll give you some time to try this and we'll take it up. I probably don't have the time to do all the computation, so tomorrow when I post the solution of the past test, I will post the solution, the full solution of the questions that I did today. Because I don't think I have time to do all the computation. Wait, I thought I changed the typo. There's another typo. Sorry guys. Here should be Z. I fixed the typo in my LaTeX file, but for some reason didn't compile correctly or something. Let me check. If that's the case, there is another typo, which I'll tell you later. Okay, I forgot to recompile before I downloaded. So this is the one with different typos. Yeah, same for example 1. I fixed it before and forgot to recompile. I'll send you the correct one now. Okay. Tutorial 4. So the one in the chat is the one without typos. I will use the correct one as well. Okay, now it should be correct. Yeah, I think I fixed it before, but I forgot to recompile. Now it's the correct version. Are you guys finished? I wanted to show you a graph, but the graph on GeoGebra is not complete. It's kind of annoying. Oh, actually, I can do positive direction only. Give me a moment. Let me set it up. Oh, still not complete. Hmm. Yep. I guess I'll draw the graph myself because the graph is not complete. So actually I'll show you. It's too hard to draw. Takes too much time as well. This. So if you look at this graph, okay? Let me change the color. How do I change the color? I don't know how to change the color. Click on the shape. This shape in the graph. Oh, nice. Thanks. Okay, there we go. So if you look at this, okay, the purple one is y equals to x 8 minus x squared minus z squared, and the red one is y equals to x squared plus z squared. So I told you the graph is incomplete because it's missing the part here. But you can tell that, well, the solid is going to be something looks like this. Okay? So let's go back to my iPad. Well, at least now you know what it looks like. So I calculate their intersection, which is around this circle, 1 y equals to 4. So the projection of E onto the xz plane is going to be the disk x squared plus z squared is less than or equal to 4. So the projection, only to show you again. Let me show you. So the projection to, so projection is like here. So project on this. Okay? Project on this xz plane. Don't know if you can see it. On this x, this is x, this is z, and this xz plane is gonna be like this. Okay? So you can tell that it's a circle with radius 2. I hope you can tell. Yeah, like this. So this circle. Back to my iPad. Oops. So that is our D. So let's write down our D and E. So E is gonna be x, y, z such that x squared plus z squared is less than or equal to y less than or equal to 8 minus x squared minus z squared. And also x squared plus z squared is less than or equal to 4. And your D is just gonna be xz such that x squared plus z squared is less than or equal to 4. So as I showed you before that circle. Now, using the polar coordinates, now let's just compute the volume. So volume equals to triple integral of E dv, which equals to double integral over d of x squared plus z squared to 8 minus x squared minus z squared dy and then dA. So this equals to 8 minus 2x squared minus 2z squared dA. Now you can convert this to polar coordinates. So that's gonna give you 0 to 2 pi, and then r is from 0 to 2, and this will be 8 minus 2r squared r dr d theta, and the rest you can just do it yourself. Okay. Any question about this one? Anyone has any question about this question? Okay, if not, let's do example 3. So I have triple integral over b, where b is my unit ball, okay, which is like a sphere with radius 1. And I want you to compute that cube plus sine y plus 3 dv. Again, I'll give you 3 minutes to work on this. This one is pretty simple. Can probably finish in 2 minutes. Yeah. So I'll give you 3 minutes to work on this, and I'll take it up. Well, in that case, I can finish writing here. Try example 3, and I'll finish writing example 2, since you guys are trying to do that. 0 to 2 pi, and then integrate this r. Okay, so 0 to 2 pi d theta, 0 to 2, 8 minus 2r squared. You can just do 8r minus 2r cubed dr. So that's gonna give me d theta is theta from 2 pi to from 0 to 2 pi. This is over 2, so 4r squared minus 1 over 2 r to the power 4. 0 to 2, 2 pi times 16 minus 8. Yeah, 16 minus 8. So that's 8. 2 times 8, 16 pi. All right. So this question, we can write this integral as triple integral over b of that cube plus triple integral over b sine y dv plus triple integral over b 3 dv. But notice that this is an odd function, this is an odd function as well. And also our ball is symmetric about xy plane, xz plane. Okay, this is a function of z, and it's symmetric about xy plane. So this whole integral will be 0. This is a function of y, and it's symmetric about xz plane. That makes this integral 0. So eventually, this whole thing equals to this. Alright? And for this integral, it's basically the volume of the ball, 3 times the volume of the ball. So you can just use 3 times volume of the ball, and the volume of the ball is 4 over 3 pi r squared, where our r is 1, so eventually you'll get 4 pi. Any question? Make sure you know this. I think you learned this in 136. When your integrand is odd and it's symmetric, then it equals to 0 because they cancelled out. Okay, so make sure you know this. That's gonna make your life much easier if you realize that. So yeah, it's really neat. Anyway, any question? If no question, oh, the thing that you need to make sure is that your region B has to be symmetric about the plane that does not. So if it's a function of z, then it has to be symmetric about xy. If it's a function of x, it has to be symmetric about yz. If it's a function of y, then it has to be symmetric about xz. So that's what you need to be careful with. Other than that, it's pretty simple. Uh, so let's move on to the next topic, cylindrical coordinates. This is really similar to polar coordinates, so if you know how to do polar coordinates, you should be able to do this. So as the same as before, our x is r cosine theta, y is r sine theta, but in this case you have a z, and z equals to z. So just add z equals to z, and everything else is the same. And here it says if your E is a type 1 region whose projection D onto xy plane is conventionally described in the polar coordinates, the wow, another typo. Suppose, I don't know why I have this here. Suppose f is continuous and your E is like this. This is type 1 region. Then and your D is given by polar coordinates like this. Then this is how you compute your triple integral. So you use this formula. Let's look at an example. So I want you to sketch the solid whose volume is given by the integral and evaluate the integral. Okay, try this. Oh, this looks pretty ugly. Okay, I have a ugly graph, but you know what I mean. Hopefully you know. So the region is gonna be E equals to xy. No, not xy. It's cylindrical coordinates. So r, theta, and z. R, theta, z, such that r is in between 0 and 2. Theta is in between 0 and 2 pi. And my z is in between 0 and 2. No, 0 and r, sorry. Okay, so that is this represents this. So here is a core. I should probably draw, yeah, this is really ugly. Should be something like this. Okay, this is slightly better. Oops. Yeah. Draw it again. Make it smaller, lower, slightly bigger. Yeah, like this. Still ugly, but you know what I mean. Yeah, so this is the region. That's really ugly region. Yeah, but let's compute the integral. So we have 0 to 2, 0 to 2 pi, 0 to r dz d theta dr, which equals to 0 to 2, 0 to 2 pi, and then r with respect to z would be rz, and that's when z equals to r and z equals to 0. So this will give d theta dr. So this will give you 0 to 2, 0 to 2 pi r square d theta dr, and this will give you 0 to 2 r square with respect to theta. Oh, we can just do this. 0 to 2 pi d theta, and then 0 to 2 r squared dr. So this will give you theta from 2 pi to 0. and this will give you 1/3 r cubed from 0 to 2. That's 2 pi times 8/3. So that's 16/3 pi. Any question? We're running out of time. Question? Oh, I wish I can draw this graph. She can draw it better. But yeah. Do we have any question? Okay, seems like we are good. So as I mentioned at the beginning of the tutorial, the rest. So example 5 is another cylindrical coordinates question. I don't have time to cover this, but you can add that to the test. So the rest is a past test that they don't include cylindrical coordinates. So you can add example 5 to that. Probably give yourself 20 more minutes, or I don't know, yeah, or 10 more minutes. So you can do example 5 with this test and give yourself 120 minutes. It should be a really good practice. I hope it's gonna be a really good practice. So it's like a real test. And I will post the solution tomorrow, including example 5. So I'll post everything tomorrow, and you can check probably tomorrow night. Okay, that is the end of the tutorial. If you have no question, you can leave now. If you have question, you can ask me anything. If anyone has any question? Okay, so no question. Good luck on your test, and I'll see you after reading week.